Hello, my name is Mustafa Alperen. This is my Lab 3 circuits for Physics 2212. So here's just a table of contents of what I'll be going over. I'll first do the introduction for the lab, the initial sort of identification, everything like that, the details of the experiment, and again, there's no coding in this lab, so there won't be a coding section. And I'll go over the similarities and differences between the data we got and the calculations we did beforehand, and I'll answer what if or what else. So the purpose of this is to predict the behavior of circuits containing resistors in series and parallel, and to use multimeters to measure the actual versions and to see the potential differences and examine the behavior of ohmic resistors and capacitors. So the model we used was kind of like a circuit elements by voltage graph. You can see it over there. It's just like the timeline of when the elements arrive, such as the resistors and the batteries and ammeter, and how the voltage decreases or increases according to those. Fundamental principles are Ohm's law, which state that electrical current flowing through any conductor is directly proportional to the potential difference between its ends, which is V equals IR, as well as combining resistors in parallel and in series. In series, you just add them up to get a net result, and in parallel, it's 1 over R total equals 1 over resistor 1 plus 1 over resistor 2, etc. And the preview, our main result is that we were able to successfully predict potential differences after each element of the circuit, as well as current after each element of the circuit by using Ohm's law, as well as combining different resistors. So initial identification of the experiment. The system of our experiment would be the battery, the wires, resistors, capacitors, light bulbs, multimeter, basically everything else we have in the circuit. The surroundings would be anything else, such as my hand, the table, the computers around it, and stuff like that. Some initial conditions. Both batteries are 1.5 volt batteries. The resistances are 47 ohms and 100 ohms for the two resistors. The multimeter functions well. The capacitor is 1 farad and the bulbs are 10 ohms and 20 ohms respectively. Possible sources of error is that if something other than, such as like the wires were touching the ends of the resistors, it's possible that current or voltage was changed at certain points. And this could have been happened, so we measured this with the multimeter several different times to try to mitigate this. But again, this could have happened very easily as circuit leaks. So the details of our experiment. First, we'd connect the two batteries to each other in series. Next, we'd attach a wire to the battery, the other end to a 47 ohm resistor, then attach the other end of the 47 ohm resistor to a wire, and then to the 100 ohm resistor, and then connect the resistors end to the negative end of the battery, and then the first circuit would be complete. For the second circuit, we'd remove both the resistors and place in a capacitor instead of where the first resistor was, and then connect two light bulbs after the first capacitor, and then connect that back to the negative end of the batteries. So some similarities and differences between our data and calculations. We did calculate that the current after the resistors would have been 3 over 147, which we got from Ohm's law. The total voltage is 3 volts, and the total ohmic resistance after both the resistors would be 147. So 3 over 147 should be the current, which is roughly 0.20, and that's what we got using our multimeter. And the potential difference across the 47 ohm resistor was 0.99 when we calculated it to be a tiny bit lower, and the potential difference would be across the 100 ohm resistor was slightly higher, like 2.08, and that was higher than calculated. And so what else? What if we charge a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. Use an ammeter to measure how long it takes to charge the capacitor when connected directly to the battery, and the ammeter. Discuss why the measured time is different from the predicted time. So theoretically, without any resistance, the capacitor should get instantaneous charge. However, because there is going to be like resistances, say across the wire, across the capacitor, such as and there will also be component imperfections. There's not such a thing as a perfect component. So there is going to be some amount of short charging time. It's not going to be instantaneous like the theory because there will be some friction and some sort of resistance to that. And yeah, thank you for listening.